Okay, let's talk about the square first. Square. Here's a rectangle. What we discussed yesterday. Here, there's a rectangle. How do you make a rectangle into a square is my question. How do you make a rectangle into a square? Any idea? Caitlin? I don't, too much info. Caitlin said do all four sides equal. Too much. Scale it down for me. Which two sides? Because remember, these two are already equal anyway. Square. There's a square for you. Rectangle with two consecutive sides. I got a square. Let me keep challenging you. What's this right here? It's a rhombus. How do I make a rhombus magically turn into a square? Give it a darn right. Give it a right angle. It's a square. Perfect. You're picking this up now. All right. So that's how I make a square from a rectangle and rhombus. Now, do you remember where the square was on our family tree? So I don't have to bring it back up again. Where was the square? Underneath parallelogram, rectangle, rhombus, and then you had the square. And why was the square at the bottom?
Because it has the properties of all of them.
Everything. Every property we have mentioned to each other this week and last week, the square has. So why do I only have two listed? I'm not listing out all of them. No. Let's make it easy on ourselves. Ready? Property number one, all rectangle properties. Done. All rectangle properties. And then what do you think I'm going to write for property two? All rhombus properties. Well, Mr. Carlino, why aren't you writing all parallelogram properties? Why am I not writing that? It's already in rectangle and rhombus. Done. So here basically sums up every single property. Done. That's a lot, isn't it? And you're about to apply it to an algebra problem here. Woo! Let's go, honors kids. Let's go. Friday. You get 2 days off to recoup. Let's finish on a strong note. Finish. This is a square. One diagonal is 16. What's the perimeter? 16. Done. There you go. There's your little 16 diagonal. All right. I should just be assuming you guys know this, but I do have to ask. What's perimeter? Perimeter? Maybe I should have asked. How do I find perimeter? All sides added up. What's so special about the sides of a square? They're all the same. So you just have to find one, multiply by 4. Good. All right, well, how am I going to find that one? Which all I know is a diagonal is 16. And again, you have every property imaginable to you. How am I going to get to a side of a square just knowing one darn diagonal? Whoever wants to go here, take the glory. Okay, here we go. Just a guess, says Avery.
So, the other diagonal.
So draw the other diagonal in. Is that what you're telling me?
Yeah.
Okay. As I do, what's happening, everybody? First of all, this diagonal I'm drawing in, how long is it?
16.
Diagonals are congruent. Oh, that's not what I want. And what am I doing in the other diagonal? Oh, so can you tell me what all 4 pieces are equal to? 8. Yep. All right, we're getting somewhere. Just nothing. Just nothing. There we go. Better. So 8, 8, 8, 8. Yep. All right, keep going. I need to get to the side. How's that help you? We're getting there. All properties. All properties exist. Serena, what's up? Whoa, whoa, whoa. Watch your mouth. Pythag is only for right triangles. But they're diagonals. What do I know about them as well? Perpendicular. That's a rhombus property. So it's a square property. Now I can do Pythag. Yes. But I just wanted to make sure we understood why they were right triangles. A squared, B squared equals C squared. What's going in for A and B? 8 squared plus 8 squared equals c squared. Keep talking here to me. 64 plus 64 equals c squared. What do we have? 128. What are you doing to get rid of the squared? What do we usually do here? Square root both sides? Haha. Don't even think about touching your calculator. Do you think I want that decimal in an honors class? Absolutely not. What am I going to ask?
Simple radical.
Break it down. Break down 128. I don't want a decimal. Come on, you're above that. Anybody know a perfect square? Do you guys know that song actually? That MC Hammer? Can't touch this? No? Where he goes, break it down? I know that. That's why I'm asking you. I'm referring to you right now, Lauren. Yes. I thought that might have been, you guys are too young for that. But yes, that's what I always think about when I say break down a radical. Hammer time. Break it down. Look it up on your, I don't know what you guys go on anymore for your music. Apple, whatever, YouTube. So what is the biggest perfect square that goes into 128? Because it's not 4. Didn't we?
60.
8?
Well, 64, but that.
Okay, well, it's not 8. I don't want 8. That's not even a perfect square. Biggest one, Charlotte? We already found it. It's already in the problem. It's 64. Yep. So 64 and 2. So what's one side length? 8. Radical 2, right? Perimeter now. I heard all about the stories in period 2 of your middle school days dealing with radicals and how you did absolutely nothing at the end of the year and you didn't even have to, you logged on, turned on your camera, and then the teacher was like, oh, we're good to go. People handing in blank Google Docs and still getting credit for homework. I heard all about it, which made me sad because you're not even going to come close to that with me in here. Oh boy, here we go. What do I do with 8 radical 2 to find the perimeter? This is going to be sad. Okay, multiply it by 4. Easier said than done. This is going to make me sad. What's the deal here? 4 times 8 radical 2. Think you got it there, superstar?
Yeah.
You were there that day in class?
I don't know, but just guess. Is it 32?
You multiply the 4 and the 8. And, I'm going to keep telling you these stories. This is the point where we're at second period. I'm like, all right, yeah, you got to multiply 4 and 8. So one kid go to the calculator, another kid go to the Chromebook, and I'm like, what are we doing? What are we doing? I'm just figuring out what 4 times 8 was. I go, you're in honors. Have some self-respect. Oh, boy. 32 radical 2. And I know that there's probably a handful of you in here. I would have done that if you just didn't say anything. Questions? All right, shocker, what's coming up next? Yep, little coordinate geometry proof. Yes, I know, go ahead. Just let it out. Don't hold your excitement back. Let it out, yep. We still have to do a kite. What's so much fun to go here in class? These last 23 minutes. Big spelling bee next Thursday. Big spelling bee. We're going to have a winner. And then we're going to vote somebody out. Happy holidays.
Wait, we have to vote
Yes,
someone out?
each class will be voting somebody out. The winner of the spelling bee cannot be voted out. The words, if you want to start studying this weekend, because I'm sure you got free time as you're balled up in the corner of your room, wishing you had some friends. The words will all be math-related words. Algebra, calculus words, geometry words. Statistics words. Statistics. How about that one to begin with? Anybody? Statistics. No writing utensils are allowed.
Like this.
You can do the air stuff like they do on TV and here. If you kind of want to bring in a big placard with your name on it and do it there, sure, go ahead. All right, whatever floats your boat. Okay. Whew. All right, let's do this. Part A. Rhombus. Prove it a rhombus. Easiest way we're going to do it is what? Four sides congruent. What formula do I need? Distance. Okay, let's start. I have news for you, though. You don't have to use distance on all four sides here. Distance formula is not needed to find the distance of AT. Why not? Because you should have the ability to count. Anybody count? I guess all you need is fingers, not the distance formula. All right, how long's AT? 5 units. Good. And then also I can do the same for MH. Also 5 when I count. Now I get it. Some of you are real sneaky in here. And you take whatever shortcut is possible. That's fine. Borderline lazy, but it's fine. So here's what I'm not going to accept. You've already determined you should get a 5 out. Oh, AM. 5. I'm done. No. You show me how you got 5, please. Okay, sorry. Good try, though. Show me how you got 5. Charlotte, what's up?
Is anything we're proving as a rhombus or a square? Can we just get 2 consecutive sides instead of all 4?
No. Because look, I'm going to introduce a kite today. And a kite has 2 consecutive sides congruent. See, when you tell me this, I could always think of another figure that still holds that property. But when you show all 4 sides congruent, there is no other 4-sided figure out there that has all 4 sides congruent other than a rhombus.
And square.
Well, bare minimum. Square, I need more info. Watch yourself there, tough guy. All right? It's at least, let me put it this way, Paul. It's at least a rhombus. So just showing me 2 consecutive sides won't be good enough because that possibly could still be a kite. So again, going back, I told you guys you got to show me more work to find AM is 5. Distance formula, I subtract my x's. AM. -2 minus 1 all squared plus 5 minus 1 all squared. I'm hoping you guys end up with 3 squared and 4 squared. And lucky for us, what's underneath the radical? Anybody getting the number underneath? 25. Thank you, right? 25. Perfect. Literally. All right, nobody got that one either. Okay. That's going to be equal to 5. That is one thing I miss doing. I used to do it because you guys know what the homework is every night. It's on the darn packet. It's on Aspen and wherever. I used to hand out an assignment sheet every Monday that had a list of all the homework assignments for the week, when the upcoming test or quiz was going to be, and then I had a little joke of the week at the bottom. I do miss those.
You start putting them up like on the presentation.
Just put the like every Monday, just put like an old one up.
Like a random spot.
I'm just wasting time here. Sorry, but it's important. Let's see, probably did I do it 2019 geometry? Ooh, assignment sheets. There they are. So December. Let's see, which one would I have this week? The 17th. So I would have had this one. A little clip art. It was great. Quadrilateral quiz 1 coming up. All the homework for the week, and then the old joke of the week. Why was the elf depressed? It had low self-esteem. Anybody? Low self-esteem? All right, never mind. That's why I stopped. And then let's see if I can find one. If there was like a big event coming up, like a dance or something, I'd have pickup line of the week because I know some of the fellows would need it. I've seen the clientele in here. Maybe this week here. Nope. What kind of pasta do witches eat? Spaghetti. How can you not laugh? Just laugh. God. Come on, I gotta find it. Where's at least one pickup line? Why wasn't the nose on the basketball team? It didn't get picked. A little gross there too, but hey, picking your nose humor, why not? Nope. What's weirder than a talking dog? A spelling bee. Where is one of the pickup lines? What did you do today in math? What we did old? Oh, there it is. One pickup line if you were a parking ticket in a previous life because you have fine written all over you. There you go, fellas. Use wisely, fellas. All right, use wisely. All right, use wisely there. All right. All right. Good little break there. TH, hopefully you found the same thing. 3 squared plus 4 squared. Square root of 25, so 5. So now in step 2, remember what I always want in step 2? What did you just prove? Again, you shouldn't be telling me you just proved a rhombus. You proved what about AT, MH, AM, and TH? They are all congruent. AT, AM, congruent to TH. What's the other side I'm missing? MH. Because distances are equal. MT is a diagonal.
Oh, then I put the letters all wrong.
Because distances are equal. Now what do I know the figure is? This is A. Okay, math is a rhombus. Why? Because? Okay, fine with me. All sides equal, all sides congruent, whatever. Rhombus is nice, huh? So is parallelogram. Rectangle is the one we got to work at. All right, and then there's a second part. Now prove to me it's not a square. So show something that usually isn't a square doesn't happen here. What's your, what do you think here? Show there's not a right angle, right? Now, do I have to show all 4? No, just show one right angle's not there and it's gone. All right, it's not a square. All right, ready, Claire? Pick which angle you want to prove is not right.
Angle M.
Angle M, got it. So what formula am I going to need to show that there's no right angle? Slope. Here we go. Step 4. Slope of, you said angle M, right, Claire?
Yeah.
Okay, so I'm going to have to find the slope of MH and compare it to the slope of MA. MH, we got to review this. Horizontal line, slope. I can't do rise over run for a reason. Go on. 0, correct. Any horizontal line has a slope of 0. On homework, you may get a vertical line. Slope of a vertical line? 1. Infinity.
No, with all numbers.
No. No slope. Cannot be found. Undefined. Yes, cannot be found for vertical. All right, go ahead. Quick rise over run to find MA. Looks like it's -2. All right, not the answer, but it's negative also. Sorry. What do you got for the rise over run there? -5 over 5? Is it?
I got -4 over 3.
You kidding me? It is your bad. What can we say about MH and MA? They are not perpendicular. All right. MH. Look at this. Ready? Perpendicular. Nope. You like that little symbol? MH not perpendicular to MA because, you tell me why now. Why are they not perpendicular? Jeez, I got all these assignment sheets open now. 5. Hi, Greg. Why are they not perpendicular? Great wording. Slopes are not negative reciprocals. So this bad boy is not a square, huh? Math is not a square. You could also say in this step too that there's no right angle at M. That's fine. But we're pretty confident math is not a square because why is it not a square? 16, why isn't this a square? Correct. Now, be careful with your wording here. Don't tell me because it has no right angles. Because I didn't prove that. I just proved it is not a square because which angle? Angle M is not a right angle. I don't want to say that it has no right angles because I didn't actually show all 4 of them. I just showed angle M is not a right angle, and that was good enough. Any questions there with that one? Yeah, I know, they're a little bit longer, so we got to suck it up. All right, you ready for the old Kyle the Kite? A kite, no parallel sides. That's why it's all by its lonesome on the family tree. It's all by its lonesome, no parallel sides. But take a look. It does have 2 sets of congruent sides. Are they opposite each other? No, they're adjacent. The 2 sets of congruent sides are adjacent. So let me go through real quick. First property. And actually, there's not going to be a 4th one. There's just going to be 3. First property, 1 pair. Ready? 1 pair of opposite angles congruent. Ooh. Oh. 1 pair. Not both, just 1. So now the next question you're going to ask is what? Which pair? Right? Which pair? A and C or B and D? Which pair are you talking about there, Carlino? The ones that are formed by the non-congruent sides. The pair of angles that are congruent are the ones formed by the non-congruent sides, which would be what in our diagram? Which 2 angles are formed by the non-congruent sides? B and D. That's how you find the pair that are equal to each other. Correct. B and D. They're always the ones formed by the non-congruent sides. Draw on your diagonals of the kite. Draw on your diagonals of a kite. Connecting opposite vertices. I think it's safe to say they're not congruent, but they are. Take a guess. Darn right, perpendicular. Diagonals are perpendicular. So they form right angles. All right, I don't want to really tell you this last one here, number 3. I want you guys to figure it out on your own. Do you see the 2 triangles up top we've created by the diagonals? They're congruent. I just want to know, it's got a reflexive side, it's got the right angles in these. Anybody know why they were congruent? What method? Oh boy. HL. Yeah, good. You were going to say that, Jonathan? Good, HL. Oh, you got to love these last 2 days, huh? You were all about this warm weather, huh, Jonathan? Shorts for days, right? Have you been wearing them all week? It's going to snow tomorrow.
Yeah, I'm fine.
Still going?
Yeah.
Even in the snow? Man, good for you. I'm a wuss when it comes to that. Good for you. Yes, here you go. So they're congruent by HL, which means, ready? CPCTC is going to say, isn't this piece here equal to this piece? Agreed by CPCTC. You just found the 3rd property, which is Longer diagonal does what? Thank you. Bisects the shorter. Yep. Longer diagonal bisects shorter diagonal. And I'm not going to go property 4. I'll kind of describe it as we do these examples. Longer diagonal bisects shorter diagonal. All right? All right, you ready? Let's use those properties and hit up these 3 examples and get the heck out of here and have a great weekend to behave. Anybody big plans? We're just all curled up in the corner of our rooms this week. Happens. Hi, Lauren.
I'm going to see the new Spider-Man movie.
New Spider-Man movie. Nice. Nice.
Oh,
I'm going to the Cowboys game.
Are you really? Really? Down at Giants Stadium?
Yeah.
Cowboys fan or Giants?
Cowboys.
No, you're not. No, I'm not.
We don't like each other anymore, Matt. Charlotte?
I'm going to New York City for a meet.
Nice. Going to the city, always a good time in the city. But you're going down there for business. It's not like you can, right, walk around and everything else. New Spider-Man movie, huh? Who's, okay, just remind me the guy's name again.
Tom Holland.
Okay, thank you. Did I tell that story how somebody said, if eat dinner with a celebrity in period 2, and they said his name, and I was like, no idea who that is. And I just got ridiculed, lambasted, everything.
Have you seen the ones with Tobey Maguire?
Now that's what I said. I said, hey, I know Tobey Maguire. Oh, he's the old one. You don't know the new, just all over me that I didn't know this Hollis guy. Sorry.
Are gonna be in this one.
Okay, I don't.
Wait, cool.
I'm not a Spider-Man guy, so.
You have an incredible Hulk show back there.
Then you don't understand though. That's not because I'm a big Marvel guy. That's what happens when you don't start doing your work and get lazy. That's the alter ego back there. All right. So that's why that's back there. Just to let kids know what happens when we get a little lazy. And the other side comes out of Mr. Carlino. All right, let's do this kite. Let's get through these here. So I have my kite. I have 101 and 48. Based on my properties, anything you could tell me about missing angle 1 and 2? Those are the opposite angles that are congruent. Correct. So I know angle 1 is congruent to angle 2. They should have the same measure. How do I find them, though? Any thoughts? A kite still has how many sides? Do you know how to find or just know off the top of your head what all those angles should add up to? Yes, 360, correct. Right? So I could do 101, and you guys can do this probably faster than I can. I'm just setting up an equation. Plus 48 plus x, because they're the same, equals 360. It's okay to get a decimal. It's fine. Don't freak out. $105.5. How's that look? No? I don't know. Everyone's shaking their head at yes and giving me thumbs up there, Kane. What's your deal? 0 for 2 today. Add 101 and 48. Move it over. Divide by 2. Algebra. Hi. Have we met? Okay. Just making sure you guys have met up before. Everyone else all right? Okay. Let's get to 2 here. I think we'll be able to finish 2. If we know our properties above, angle 1, pretty quick, should be. Diagonals are perpendicular, so that should be a 90-degree angle. All right, how can I get to angle 2 now? Again, I don't necessarily have to use a kite property. That's 90. Isn't the angle next to angle 1 adjacent to it 90? Do you guys see a triangle where you know 2 out of the 3 angles? Yeah, right here, this one on the top right. So I could do 180 minus 90 minus 27. Everyone see where I'm getting that from? No kite property, other than I guess the diagonals are perpendicular. So angle 2, what was that one? 63? How's that look? All right, here is where I'm going to end class on angle 3. And this is what I probably would have written in if there was a fourth property. How do I get to angle 3? What's up, Charlotte?
It's the same as angle 2, right? 'Cause
Why?
the big angles are congruent, and then the diagonal, just do them, so it's the same.
So you're just assuming they bisect each other. Okay, well, you are correct, but here's how I get there. Hey, when I draw the shorter diagonal in, what type of triangle did I just highlight? Aren't both of them isosceles, right? And then you guys definitely know what's across from the congruent sides. Okay? Look for those isosceles triangles when you are working with kites. All right? Look for those isosceles triangles. And I think I'm not even going to try to get to the next one. That's where we'll end it today.
Wait, this is how easy.
Spaghetti, Paul. Spaghetti. That's what they eat.
Is the longer diagonal bisect that one angle?
That's what ends up. Yes, that is. But I just don't. Yes, you are correct. I don't want to keep listing properties, but you are correct.
Yeah. I'm gonna come up with like I'm going to come up with
Low self-esteem, everyone. He had low self-esteem.